Hello friends, you might be using this ultrasonic sensor just to measure the distance. But along with measuring the distance, it can also sense the direction of movement of obstacle in front of it. Okay, as you can see on your screen, the program is printing the object move from left to right or right to left. Now let us start making the circuit connections, and before that let me show you the pinout of this sensor. So trig pin is used for the transmitting of ultrasonic waves, and echo pin is used for receiving of the ultrasonic waves after they get reflected from the object. And VCC and the ground are obviously for the power. Right, so place the ultrasonic sensor on the breadboard, and you must keep in mind that there must be a sufficient distance between both of the sensor. Otherwise, if you keep very less distance between both the sensor, what happens, the obstacle can be detected by both the sensor at the same time. Okay, so Arduino won't be able to detect whether the obstacle is moving from left to right or right to left. Now take out two jumper wires from the Arduino, one from the 5-volt pin and other from the ground of the Arduino, and connect these two jumper wires on the positive and the negative rail of the breadboard, and connect all these three LEDs on the breadboard. So if the object moves from right to left, the red LED will glow first, then green, then blue. And if the object moves from left to right, the blue LED will glow first, then green, and then red. Now we will connect the trig and echo pin of both the sensors to the digital pin of the Arduino. Now connect all the LEDs to the digital pin on the Arduino. Now this is a complete circuit connection among all the components, and you can also see the circuit diagram on your screens. Now here is the program of the project. So we are defining trig and echo pins of the ultrasonic sensor, and all the LEDs are connected to digital pins on the Arduino. And T is the time in millisecond when the left sensor detects the object, and similarly TB is the time in millisecond when the right sensor detects the object. Now threshold is equal to 25 means that if the object is within 25 centimeter from the ultrasonic sensor, then only it will be considered by the ultrasonic sensor, otherwise will be ignored. And persistence is the number of consecutive stable readings to be taken by the ultrasonic sensor before it confirms the detection, right? So persistence is equal to 3 means that if the sensor detects the object 3 times in a row in front of it, then only we will accept it, otherwise it will be ignored. Okay, now you may ask that the object passes in front of ultrasonic sensor only once, then how it will take 3 readings? So the reason is simple. When the object moves in front of ultrasonic sensor, even for a short movement, the sensor takes multiple readings while the object is still in front of it, right? So one reading happens in about 20 to 30 milliseconds. So the sensor gets enough time to take multiple readings, and here we are taking 3 consecutive stable readings, right, for the proper detection of the object. And counts are the variable which indicate that how many times the ultrasonic sensor detected the object in front of it. Okay, and they have been initialized to 0. And in the setup section, we are defining the trig pin as the output, echo pin as the input, and all the LEDs are defined as output mode, right? And initially all the LEDs are in off state. Now in the measure function, we are basically calculating the distance measured by both the ultrasonic sensors, and you are most likely to begin the function from these three lines, right? But these two lines are also highly recommended because sometimes due to previous loop iterations and electrical noise, this trig pin remains in high state. Okay, so in this line we are basically clearing that buffer high state on the trig pin by writing the low signal. Okay, and after 2 microsecond delay or 5 microsecond, you can start the readings as usual. Okay, and in these three lines we are basically calculating the duration and the distance. So pulse in is a function which returns the time in microsecond. Okay, and in this line we are basically waiting for the echo pin to go high and measure how long it stays in high position. So duration is that time, right? And if the duration is equal to 0, it means that no echo is received by the sensor, and we are returning -1. Now this is the actual distance to be measured by the sensor, right? So duration is time multiplied by the speed of sound in air divided by 2. And because and this is the actual distance to be measured by the sensor. So duration is the time multiplied by the speed of sound in air and divided by 2, because we need only one-way distance, not two-way distance. And the duration is in microsecond, that is why speed should also be in centimeter per microsecond. So 34200 is in centimeter per second. That is why we are dividing it by 1 million. So the entire distance will be in centimeter. Now coming on to the glow sequence function, here we are toggling all the three LEDs one by one. So first of all, the first LED will on for 100 microsecond, then second LED will on, and lastly the third LED will on. And in the loop section we are calling the measure function for both the ultrasonic sensor A and B. Now in this if condition we are basically checking that whether the object is within 25 centimeter or not. If this is so, then we are increasing the counter on A, and we are further checking that if we have got stable 3 readings on the left sensor or not, right? And if we have got 3 stable readings, then we are recording the time of detection TA using the millis function. Okay. Otherwise, if the object is out of the threshold, then it obviously the counter will be 0. And similarly for the right sensor. And in this portion of the code, we are basically determining the direction. So direction will be determined only when both the sensor have detected the object. So this is that condition. And if TA is less than TB, then the movement direction will be from left to right, and the LED pattern will be this: blue, then green, then red. And if TA is greater than TB, then the glow sequence will be this: red, green, and blue. Okay, and we are resetting all the variables for the next loop iteration. So if you really enjoyed this video, subscribe to my channel and share this video. And if you want me to add some modification in this project, then comment down below. Till then, keep tinkering.